With the graphing, the first thing you had to draw was a bar graph. So they're clearly telling you what type of a graph. Remember, a bar graph is not the same as a histogram. There need to be spaces between the bars. And E is your coefficient of restitution, which tells you how well a ball bounces. It has no unit. So if I'm going to draw a graph, I'm going to firstly have to give my graph a heading. Graph of y versus x. So coefficient of restitution of various balls on a wooden floor. What is on the y-axis? What did I choose? I chose the ball, so that is on the x-axis. It is the independent variable. And on the y-axis is the dependent variable, in other words, what I'm going to measure, and I get the coefficient of restitution, and I write the whole word out, coefficient of restitution. It doesn't have a unit, and nor does type of ball have a unit. So that is how you're going to do that. Remember, it's not a histogram. There must be spaces between the bars. What is the conclusion? By the way, this height should have been in centimeters, not meters. What is the conclusion that you can draw based on this particular graph? Well, you can see clearly there's a trend that as the years have gone by, people have landed up jumping higher and higher heights. Draw a graph using the data. Plot the graph of friction versus the speed of the bicycle. So it's y, so friction goes on the y-axis and speed goes on the x-axis. From your graph, determine the speed of the cyclist when she experiences air friction of 180 newtons. So we're going to take a look at that. And when the cyclist crouches lower, she travels faster. Explain why. So here's a nice graph. As you can see, it does not come out as a straight line. You get a nice smooth curve going up like that. That is your best fit line. I didn't play join the dots. I've got a smooth curve going through there. And then friction is on the y-axis, speed is on the x-axis. Evenly scaled, 50, 100, 150, 200, 200, 250. Evenly scaled, we started at 0. This axis could be over a little bit. 1, 2, 3, 4, and 5. At 180, it correlates with 4,8 meters per second. And if she goes faster, when she crouches, it is because she has reduced the air friction. Next one, plot a graph of current y versus x. So the current goes onto the y-axis and the potential difference goes onto the x-axis. And then it asks you to determine the gradient of that graph using the formula. So first, your graph needs a heading, graph of y versus x. Y is on the y-axis, x on the x-axis. Notice I go up evenly, 1, 2, 3, 4, 5, 6, 7. I go up evenly, 0.51, 1.52, 2.5, 3, 3.5. Notice that I've got the units in both cases on the axes. If I want to work out the gradient, y2 minus y1, so I go to 1.5 minus y1, 1, and x2, 3 minus 2, and I get an answer of 0,5.